All right, the quadratic formula, really one of the most important formulas in math, next to Pythagorean theorem, because it's so useful in so many different situations. Basically, is this. If ax squared plus bx plus c equals 0, most important, equals 0, then negative b plus or minus the square root of b squared subtract 4 times a times c divided by 2 times a can be used to find the solutions to the equation. Find all the solutions to the equation. This is the quadratic formula. That itself is the quadratic formula. Just nursery rhymes for them and all sorts of stuff, but just know negative b plus or minus the square root of b squared subtract 4ac divided by 2a represents the quadratic formula. The sooner you memorize that, the better. All right, but you know what? With every problem you do, if you write this down every time you do one of these problems, you have to memorize it, and you have to memorize before the night is over, or maybe before tomorrow is over. All right, so I'll get that as a note. I want to go further. All right, first example says solve the equation 3x squared subtract x equals a 4 for x. Lots of ways we can solve it. However, we want to focus on the quadratic formula. So what's important is the first thing must be get one side equal to 0. So given that equation, I want to get one side is 0, so I'm going to subtract 4 from both sides. Giving you 3x squared subtract x subtract 4 equals a 0. Now what you want to find out is what is a, what is b, and what is c. So we looked at this. A has to be 3. B has to be this number, which is understood -1. And C has to be -4. From there, you want to plug them all into the quadratic formula. And every time I do it, I always write down what the quadratic formula says. For one, it just helps you memorize it, if nothing else. It also keeps everything in the right place. Negative b plus or minus b squared subtract 4ac all over 2a. So this now gives you -1 plus or minus the square root of -1 squared subtract 4 times 3 times -4 all over 2 times 3. And this is now equal to a -1 is a +1 plus or minus 1 squared is 1, and then subtract 4 times 3 times, well, this is a -4 times a positive times a negative. I got an even number of negative signs, so that's going to be a plus. So it's going to be 12 times 4 is 48 all over 6, which is nice because that gives you 1 plus or minus square root of 49 over 6. So it gives you 1 plus or minus square root of 49 over 6, which is 1 plus or minus 7 over 6. Now clearly I'm out of space, I'm going to move it up here. So that means 1 plus 7 over 6, and then 1 subtract 7 over 6. So this is 8 over 6. This is 8 over 6, and this one is, another one is -6 over 6. So 8 over 6 used to be 4/3. -6 over 6 gives you a -1. So my solutions for x has it equal to -1 and 4/3. So apparently if I plug in -1 into this equation, I get a true statement. If I plug in 4/3 in that equation, I get a true statement. I got multiple ways of checking now. I could graph it to check it. I could plug it into the equation to check it. And I could check it by trying to factor it. For example, this may be factorable, and I could factor it to find the solutions to it. So anyway, that's how we use the quadratic formula. That's why it's useful. Take it straight to the answer every time. Let's do a couple more of those, though. I'll get that down as a note, though. All right, so we have a new quadratic equation. In order to solve this, our first step is get one side to be 0. So I'm going to move all this stuff over to the left side. I'm going to subtract 6x. I'm going to add 11x in the same line. Subtract 6x, add 11x. So on the right side of this equation, that cancels, leaving with 0. And on the left side of the equation, I get negative x squared. Negative 2x, negative 6x is negative 8x. 11 doesn't have anything to add with other than 0 there on the end, so it's just plus 11 on the end. So now I want to find A, B, and C. A, B, and C. A in this case is negative 1, B is negative 8, C is positive 11. And I'm going to plug into my quadratic formula, which is negative b plus or minus the square root of b squared subtract 4ac all over 2a. And then go to evaluating that stuff in there. And after you evaluate it all in, or you don't say evaluate, after you plug it all in, all right, so after you evaluate or plug it all in, you should wind up having this. And after you get to this, you should simplify it. Negative negative 8. Well, this is positive 8 now. Plus or minus the square root of 8 squared is 64. A negative and a negative is a positive now, so I got a plus sign here. So 4 times this is 1 times 11 is 44. All over negative 2. So this now gives me 8 plus or minus the square root of 108. All over negative 2. 108 does have a perfect square into it, and I can figure out what that is. I'm going to go call that a decimal. I'm going to go to square root of 108. Before I square root it, let's go and work with it. 108 is really 36 times 3. How do I know that? I just checked it out. But it's going to be 36 times 3 gives you 108. And divided by negative 2. So I know square root of 36 is 6. So this is really 8 plus or minus 6 square root of 3 all over negative 2. So if both of those outside the radical can be divided by negative 2, some students just want to divide, that's the first term, it doesn't work that way. You have to divide each of these terms by negative 2. So I'm running out of space, I'm going to move it over here. So this basically means negative 8, this means not negative 8, positive 8. Positive 8 divided by negative 2, plus or minus the second part, which is 6 square root of 3 divided by negative 2. So you got to divide each part by that negative 2. This piece gives you negative 4. The second piece gives you a negative 3 square root 3. So negative 4 plus or minus negative 3 square root 3. Well, that's just what it is. And these are my solutions to it. These are my two solutions to it. One of them is negative 4 plus negative 3 square root 3. Another one is negative 4 subtract negative 3 square root 3. A mature algebra student would go and call that negative 4 plus negative 3 a subtraction. So you could call it negative 4 subtract 3 square root 3. And you saw a double negative, you should go and call that addition. So those would be two solutions. Now, truthfully, you can plug that into the calculator and find out, estimate what it is, because you're not going to see this on a graph. So you actually want to see it as a decimal form if you think about graphing it, or you want to check your solution with the graph. So you plug and calculate negative 4 subtract 3 square root 3 and negative 4 plus 3 square root 3. And those values are, basically they are equal to roughly 1.2 and negative 9.2. So the actual estimates of them are 1.2 and negative 9.2, or the exact values of what we have there. So that's how we can use quadratic formulas to solve equations. Let's talk about some other usefulness for it, or just some other facts about it. All right, so in the formula, this piece underneath the radical, this radicand, is called discriminant. It has special properties. Why it's called discriminant, I don't really know. They just call it discriminant. But it has special properties though. And the properties of it is this. If that discriminant, b squared subtract 4ac, if it's positive, it tells you that you have two real solutions. So if that's positive, you got two real solutions. If it's negative, if b squared subtract 4ac equals to a negative number, you won't have any real solutions. You have imaginary solutions. So if it's equal to a negative number, you get two imaginary solutions. And the last thing could be is if it's equal to 0. If b squared subtract 4ac equals 0, then if it's 0, then you have one real solution. Exactly one real solution. So basically, a graph that has each of those examples, a graph with two real solutions. So it's positive two real solutions means that graph, the parabola, would touch the x-axis twice. Here's here, and that's another one. It might be upside down and be a parabola going this way, but it will still touch x-axis twice. If it has no real solutions and all the solutions are imaginary, well, it'll still be a parabola, but it would look like this. There'd be some parabola that doesn't touch the x-axis at all. Be above it, so it doesn't have a cross, it doesn't have any real solutions. It might be beneath it. That doesn't cross, it doesn't have any real solutions. And the last example is when they have one real solution, it would touch x-axis once. So you got this graph, and it would just barely tap the x-axis. It wouldn't actually go through it. It would sit right there on top of it, or it might be right beneath it and just barely touch it. It'd be tangent to the x-axis at some point. So that's what they look like. That's what the discriminant is useful for. If you actually see what that value is, you can kind of figure out how many solutions you should have and whether those solutions should be real or imaginary. If that discriminant is a perfect square, that just means you have rational solutions. If that discriminant is imperfect square, you're going to have irrational solutions. So if it's square root 25 there, you're going to have whole numbers that are real numbers that are rational. If it's square root like 17, you know you're going to have irrational solutions, so you're going to be decimals, so you have to approximate and so forth. So that's another little thing to know. If it's a perfect square, it can give you rational solutions. And if it's not a perfect square, it can give you irrational solutions. All right, so I think that's all I have. Let me make sure, though. Yeah, that's definitely it. You should have pretty decent understanding of quadratic formula. That's all I have. Good luck.